Today we're going to be looking at the compound angle expansion. So pretty much we're wanting to prove this one over here. We're going to be using the cos A minus B. So we're hoping to show that it equals cos A cos B plus sin A sin B. So first of all, we're going to need our cosine rule. You would have done that last year in year 12, level 2. So I don't like it in this form. I want cos C to be the on the left hand side here, so it's going to be 2, well, subject of my formula, so 2ab cos C is equal to a squared plus b squared. I'm just taking the c to the other side, so I get cos C is equal to a squared plus b squared minus c squared over 2ab. That is the form I am going to be using it in. Another thing we need to know is our distance formula. Oh, that's just lovely and neat, isn't it? So if I have my distance formula, basically if I have a line segment AB and I'm wanting to know what this length is, let's call it C. If I drop down and a little right angled triangle there, this length across here, my x, would be the change in that x to that x. So if I said x1 minus x2, that would give me the length of that. And if I said y1 minus y2, it would give me the length of that. Using Pythagoras, I could say that c squared equals x1 minus x2 all squared plus y1 minus y2 all squared. And of course, we usually just write it just as c, so it would be the square root of x1 minus x2 plus y1 minus y2 all squared. So remember that, we're going to come back and look at that. So those are the two things we're going to use to do our proof. Okay, now we are looking at a unit circle, well, part of a quarter of a unit circle. That means that my hypotenuse or all my radii on this circle are 1. I want to start by just showing how we can find our x and y coordinates of this A and B. So first of all, let's just look at my green triangle with my angle x, that the whole angle there, all the way to my x-axis is x. So if that's x, this side here is my opposite side, and that is my adjacent. So this is my opposite, that is my hypotenuse, this is my adjacent. So if I wanted to find my x coordinate, this length x over here is actually just that distance from there to there, and this x would be what that x was there, that distance from 0 to there. So that is going to be my adjacent over my hypotenuse. So my adjacent side is my length x I'm looking for. My hypotenuse happens to be 1, which is really handy. And adjacent over hypotenuse is cos of x. Oh, well, x equals cos of x. This value is going to just be cos of x because my hypotenuse is 1. In the same way, I have my opposite side there. That's actually my y value. That's how high that's going to be. So y over 1 is equal to opposite over hypotenuse is equal to sine of x. So that is going to be sine x. In the same way, this over here, if you have a look at it, would be cos of y sine y. Okay. Now I'm going to just call on my little cos c again. So we said that cos c was equal to a squared plus b squared minus c squared over 2ab. And in this, I'm actually going to be talking about this triangle here, this red triangle. Now remember last year when we did the cos rule, we said that if that is capital A, then that's little a side. If that's capital B, that's little b. And if that's capital C, that's little c. So I'm going to substitute all of those into here. So that means, and this angle is x minus y, because that full thing is x, that small thing is y, so it's going to be x minus y. So cos of c is cos of x minus y, and that equals, well, we already said that a and b are each 1, So I can just substitute it in there, and I get 2 minus c squared over 2. There. Okay, so I can see that cos of x minus y is 2 minus c squared over 2. Well, we still need to find out what c is. This is the side here. I'm basically looking for a line segment between two pieces. So if you remember correctly, our distance formula was a line segment between 2 points, and I was going to use Pythagoras to calculate it. So I am going to use that now. So I know that C is equal to this C over here. The change in x1, y1, and this is x2, y2. So C is equal to the square root of cos x minus cos y, all squared, minus sin x sin y, plus, sin x minus sin y, all squared. So I'm going to move this over here for a little bit so we can work this out in space. So first of all, I'm going to square both sides to get rid of my square root. So I get c squared is equal to cos x minus cos y all squared plus sin x minus sin y all squared. Now I'm going to multiply out these two brackets. So that's actually what it's saying, plus sin x minus sin y times sin x minus sin y. Okay, and so if I multiply that out, I have cos x minus cos x cos y minus cos y cos x, and a negative times a negative is a positive cos squared y. Similarly, I multiply that out, sin squared x minus sin x sin y, minus sin y sin x, and then negative times a negative plus sin squared y. Okay, I am just going to, so I'm going to just rewrite some of these. So I've got cos squared x plus sin squared x, and I've got cos squared y plus sin squared y, and then I've got those two, cos x cos y cos y cos x. That's the same as cos x cos y because they just multiply, to be minus 2 cos x cos y. Similarly, these two are the same, so minus 2 sin x sin y. Okay, so cos squared x plus sin squared x. Pause this now and think, what does that give you? Look at your identities. I'm just going to carry on. It equals 1, and cos squared y plus sin squared y is 1 as well. And I'm then going to have minus 2 cos x cos y minus 2 sin x sin y. 1 plus 1 is 2 minus, now I'm going to factorize out this minus 2 from both of them. So minus 2 times cos x cos y, and I've taken that 2 out, so that's going to be a plus sin x sin y, and there we go. So I have now said that c squared is equal to that, but previously I had said that cos x minus y is equal to that whole thing there, so 2 minus c squared over 2. C squared, well, I've got c squared over there. I'm going to substitute this c squared into there. So I now have cos x minus y is equal to this 2 minus c squared, 2 minus 2 cos x cos y plus sine x sine y. I'm going to multiply this negative in first. Oh, over 2. Haha, don't forget that. Multiply that in first. So it's going to be 2 minus 2. That's going to be a plus 2 cos x cos y plus sine x sine y. And that's all over 2. I've multiplied that in. Those brackets are still there. 2 minus 2 is 0. 2 divided by 2 is 1. So I end up with cos of x minus y is equal to, those cancel because that's 0, cos x cos y plus sine x sine y. And similarly, we could prove our other one. So we've just proved that cos x minus y is equal to cos x cos y plus sine x sine y. Similarly, we could prove the other ones, but we did them. We used this to prove the rest. So there is all of your information. That was what we needed to know. Hope that helps. Ask me any questions if you need to rewind, etc.